Hi, welcome back to the session. And now we'll be seeing about a route. In route, I'm just going to concentrate on a specific topic of OSPF. So OSPF, you call it to be open shortest path first, and it belongs to a group called as link state routing protocol. So now here, when you say link state routing protocol, it's an open standard. Link state is an open standard, work with any vendor devices, not only with Cisco, any vendor devices will be working with OSPF, open shortest path first, or link state routing protocol. Now, when you say about link state, there are two words in that, link and a state. So what is a link and what is a state? Link exactly says where is your interface on a router connected to. It might be a neighbor, it might be onto a next connected device. So the link says the neighbor device, and the state says what is the mode of your connectivity, or it says over here as a description of the interface to the relationship with the neighbor. So how is a router forming a neighborship to the next router, and what is a neighborship format? So this will be called as link state. Now in OSPF, when a router comes up, say you have two routers, when two routers are coming up, see, normally they would send a message, so saying that, hey, I am router 1, I am coming up. So that message will be displayed as LSA, link state algorithm, you call it to be, or you call it to be link state advertisement. So this link state advertisement, say I have two routers, so it will send from router 1 to router 2, and the router 2 will receive the LSA, put the LSA inside a database called as LSDB. You call the database which holds every LSA to be link state database. So now every collection of LSAs will be put onto a LSDB. Now when router 1 was sending to router 2, he will put it in his database and he will further forward it to every other routers in that particular area. So it will be sent not only to directly connected routers, the LSAs will be sent to every routers in that particular area. Now here in OSPF, the algorithm which is used to find the shortest path is called as SPF. You call it to be shortest path first algorithm, or the algorithm is otherwise called as Dijkstra algorithm. Now when you say about OSPF, OSPF has three type of tables. You call the tables to be neighbor table, topology table, and the third one you call it to be routing table. So what is a neighbor table? Say, as I said to you earlier, you have two routers, R1 and R2. Say the R1 will show my neighbor is R2 with the router's IP address, with the interface connected to which type, all the details regarding the neighbor will be explained on my neighbor table. So that table in OSPF you call it to be OSPF neighbor table. Next, you have the next table called as topology table, or otherwise the table exactly or specifically you call in OSPF to be a database table. So earlier I said you something about called as a database, link state database. So the same LSDB is otherwise called as database table. So what are the contents inside a database table is every LSAs will be put together inside the table called as LSDB, or otherwise you call it to be a topology table. Now on the topology table you will be running an algorithm called as SPF, shortest path first algorithm, and or when the algorithm is running on that particular routing topology table, he will select the best path to a particular destination, say from R1 to say RZ, from RA to RZ. If I have multiple paths, the best path will be selected based on the cost. So who does that is SPF algorithm and puts the best path with the least cost into the routing table. So now what is a cost? Cost in OSPF is dependent on the interface. So here they have a command saying a reference bandwidth by interface bandwidth. So what is reference bandwidth? Reference bandwidth is always defined in OSPF to be 100, and interface bandwidth differs. For Ethernet, the bandwidth you know is 10 Mbps. So 100 divided by 10 Mbps gives you a cost of 10. Now when it is fast Ethernet interface, the reference bandwidth remains the same, it is 100, and the fast Ethernet interface bandwidth is again 100 Mbps. So 100 divided by 100 again gives you a value 1. So the cost is 1. So that is how the cost is calculated on OSPF. Now, then the next major thing you have to remember is OSPF areas. OSPF, in an autonomous system, you have multiple areas, and the area 0 over here, you can see area 0 which has router 1. The area 0 router will be called as normal area router, or the area 0 is otherwise called as backbone area or core area, or otherwise you can call it to be a transit area also. Now, you can see here R1 router which connects area 0 and area 1. So that router which connects area 0 and area 1 will be called as area border router, or otherwise in short you call it to be ABR. Now imagine you have an autonomous system, and on to the other side you can have, see, router 4. The router 4 is a router which connects OSPF autonomous system and the other autonomous system. So that router you call it to be a ASBR, autonomous system border router. So these are the basic criteria which you come across when you see OSPF. Now, when two routers, as here you can see here router 1 and router 2, when two routers R1 and R2 are becoming neighbors, what are the criteria, or what are the message exchanges done? So when R1 and R2 is coming up, there are, you call it to be 7 states of 7 steps will happen when two OSPF routers will become neighbor. So you can see here the very first state you call it to be a down state. So what is down status? So now you have R1 and R2. So when R1 and R2 are forming neighbors, they will be sending a hello message. So when the hello packet goes on, he will be using a multicast address 224.0.0.5. So when I am sending a first message, the message will be called as init, or the state you call it to be a init state, because only from my side I have sent a hello. Now when R2 is also configured with OSPF, R2 will send me a hello back. So when I am sending a hello, you call it to be a init state. When R2 is sending me a hello back, you call it to be a two-way state, because two-way neighborship or two-way hello packets are being sent. So now inside a hello packet there are so many contents, we'll discuss it. Now two routers send hello packets. The third state you call it to be your X-start state. So what exactly happens on X-start state? Say you have two type of networks basically when you configure OSPF. One is called as a broadcast domain, another is called as a point-to-point domain. So now when you see in this scenario, you see R1 and R2 which is directly connected through a point-to-point. So between a point-to-point there will be no DR BDR election. What is DR is designated router, and what is BDR is you call it to be backup designated router. Now what exactly is the use of DR and BDR is, see, inside a broadcast domain, what is a broadcast domain? So you have a switch, you will have multiple routers connected to a switch, because switch belongs to a broadcast domain. Now this switch, when it receives a message from one router, he will broadcast it to everybody. Now when he gets another message, he will so this equally happens in a broadcast net. So in order to control this broadcast, you have come up with a concept called as DR and a BDR. I'll explain you exactly how the elections happens in a DR BDR. But now on the X-start state is what DR BDR election is happening in order to prioritize who can advertise on a broadcast. Now after the X-start state, after a DR BDR is elected, or on this point-to-point you call it to be a master slave. Master will be the highest IP address, slave will be the lower IP address. Now when the highest IP address is elected, he will say, hey, I will exchange my message. So now after the X-start state, you have a state called as exchange state. So the next state is called as a exchange. So at the exchange state, or before the exchange state starts, once the DR BDR election has happened on an X-start state, at the last stage I will send a DBD. You call it to be database descriptor, which is a second type of packet in OSPF. So once this DBD is sent, what is DBD? It's called as a database descriptor. Now what exactly is the content? The whole routing table on my routing table, whole entry of my routing table will be selected as a summary. Only the summary routes from me will be sent to the other will be indicated in the DBD, database descriptor. Now, after the database descriptor, you will have an exchange state where that guy would have received my DBD. Then he will say, okay, this is my DBD. On the exchange state, I will send whole LSDB, link state database. So then what will happen is they will load the information. I need your complete information, as you can see on the slide, and he will also send my information. Then they will form neighbors. So OSPF neighbor relationship exactly goes through these steps as you see on the slide. So at the last it will say LS acknowledgements, saying that I got your messages. Then if there is some request, some messages left over, I can send LS or link state request, then I can acknowledge. So these are the 7 fundamental processes which exactly happens either in a point-to-point or in a broadcast domain when your 2 routers are coming up. Now the next step is, what are the contents inside a hello packet? We just saw what is a hello packet forming neighbors. So in this slide you can see exactly this one is a broadcast domain. Can you see R1, which is connected through a single line that you call it to be a switch, which is connected to R2, R3, R4 and R5. So now this is a broadcast domain. So now the very first criteria is called as a router ID. So what is a router ID? See on the slide you can see that router ID is nothing but how a router is known to everybody. Say I am Neil, so everybody knows me by my name. Same way in an OSPF domain, a router is known to every other routers by a name. So here what is the name used? Name used here is an IP address. So whenever a router is coming up, you can see on the first point, the highest IP address on the active interface will be called as a router ID. So what is a router ID is, say on my router I have 2 IP addresses. On one side I have 10 dot, and other side I have 20 dot. So when this router is coming up, when you configure OSPF, whoever is there first will be configured as the router ID. So highest IP address available at the OSPF moment of OSPF configuration will be called as router ID. Then the second one is, you can see loopback. Say if a physical IP address is configured as a router ID, if the physical interface goes down, if some problem happens to the interface, that interface will go down. So again a router has to select a router ID. So they have come up with an option called as loopback. So loopbacks will never go down, because you create interface loopback 0 on a router, the interface will never go down. So the loopback will be given a preference if loopback is present. Only physical interface is there, the highest IP on the physical interface will be selected. If there is a loopback address, the loopback will be given the preference. Fine. So now the third option is, we manually can define a router ID by the command router ID under the OSPF. So these are the 3 modes where you can define a router ID, and hope you are clear with what is the use of a router ID. Then the second criteria inside a hello packet is hello and dead interval. So what is a hello and dead interval is, so neighborship is formed between 2 different routers. So every 10 seconds I will be sending a hello packet. So the timer for the hello packet is called as a hello and dead interval. The hello is 10 seconds and the dead is called as 40 seconds, 40 seconds. So if I am sending a hello packet, he would expect the next hello within the next 10 seconds. If I am not sending a hello for almost 40 seconds, if it exceeds beyond 40, the neighborship will go down. There will be no neighbor relationship between the 2 end routers. Then the third criteria they say is the neighbors. So if they have to exchange hello packets, they should be directly connected neighbors. Then area ID. Say as we learned, we have multiple areas. In OSPF we have area 0, area 1, area 2, you can have so many areas. So a router which is part of area 0 on one side and which is connected to area 1 on the other side cannot form neighbors, because they should be part of the same area. So that's what they say, the neighbor area ID should be the same. Next is a router priority. So what is the use of a router priority is, see on the earlier stage when I was explaining how the neighborship is formed between 2 routers, I said you something about DR and BDR. So DR and BDR are elected based on the router priority. But by default, every interface on OSPF has a priority called as 1. The priority ranges from 0 to 255. but the default priority on all the interface is 1. So now when all the interface is having a priority as 1, there becomes a tie-up. So the next criteria he selects for the DR BDR election is nothing but the router ID. So the highest router ID will be selected as a DR. Now I said you will explain you what is router ID earlier session. I will explain you what is router ID. Now see here, you have R1, R2, R3, R4 and R5. Now if R1 is sending a hello, he will send it to every routers. If R2 is getting that, he will just get it and he will broadcast it to every. So that's a broadcast. So now that if it happens all around, your network congestion will happen. So in order to avoid this, say one of the router in this particular domain will say, hey, I am the head around this area. If anybody has to update a message to others, you have to directly send it to me and I will be responsible to forward it to others. So now the DR plays a role of forwarding the packet from a router when he receives it in a broadcast domain to every other router. So the highest router ID will be selected as the DR. So when if R1 has to send some messages to hello messages to everybody, he might send it to a router ID, he might send it to a DR, and DR will be capable or he is responsible to send it to everybody inside the area. And what is BDR is nothing but backup designated router. So if a DR goes down, there are chances that the DR can go down or the router which has a DR capability can go down. So when he goes down, the BDR takes up the next DR election. So that is a backup designated router. Then the next point is authentication password. So authentication password is nothing but if two routers has to form neighbors, their authentication should match at both the ends, both the connecting interfaces, the authentication should match. Now in OSPF there are three type of authentications. It is authentication 0, authentication 1 and authentication 2. So both routers who are forming neighbors, both the ends the neighbor should be the same kind. If R1 is having authentication 0, R2 also should have authentication 0. If it is authentication 1, the other side also should be authentication 1. The next is a stub area flag. So it says about the stub concepts of OSPF. So they will only form neighbors with the stub area flag. So out of this OSPF criteria, as you can see so many criteria inside OSPF hello packet. So out of this, if at least 4 makes up matches, they would form neighbors. Otherwise they will never form neighbors. So these are the requirements for OSPF to form neighbors between two routers to form neighbors between OSPF. So I think you have gone through the OSPF hello packets and the 7 stages of OSPF. Hope you enjoyed this session. Thank you.